Fine. So again, welcome you all. Okay, and just the continuation of yesterday's session. Are we good on the installation of R and Rstudio, or is there any challenges? Okay, I guess there should not be any challenges, but still, if there is any challenge, just mail me the screenshot of the error that you are getting. Okay, or ping me personally. I'll just try and get you back. Okay. So once you install R and then RStudio, you should be having some application that looks like this. Okay, so this is called R. Fine, this is called R application, and we'll come to the like detail of it in some time. So before we start with R, so let's start with a brief introduction of R and uh, like the tool of R. Okay, yeah. So what will be our core agenda? We'll just see our agenda. So we'll be seeing the basic principle and software paradigm. Okay, description of R interface that I'll be taking you through the R and what it is and like why it is used and why it is so famous, why it is in demand, or why people are running behind R. Okay, so all this thing we'll look at. Fine. And then we'll see advantages of R and why it is so famous in the community of analytics and data science. Okay, and if you that is a later part of the story, analytics and data science. But still, if you come talk to academic in perspective of academics, it is very famous in the academics of engineering, statistics, and economics. Okay, so we'll see the things like why it is so famous and what it gives to us. Okay, then we'll see some drawbacks of R. Okay, and and we'll see the industries where R is being used, right? And then some references. Definitely at the end of the session we'll give you some references, some links where you can explore more. Okay, fine. So let's move ahead. I'll share this slides with you. Okay, so you can go one by one and see things. But just let me take you directly through like brief history. R was invented in Bell Laboratories. Uh, you must have heard about R, right? Bell Laboratories. Give me 1 minute. There's some sound that is coming, and I need to fix that. Recording. Yeah. So there was a software called S. Okay, so R is uh, a replication of that. Okay, it's a very advanced version of S. Okay, and R was a tool that was developed few days back, and it in the recent past, in 2007, 2006, it started being used in industry. Okay, but earlier it was not that famous. Okay, it was a software called S that was used very widely, but not R. Okay, so now like there was various version of R and various version of S that is being used from a long time. Okay, and then to a statistician, okay, from New Zealand, they found they are not able to implement some algorithms, mathematical algorithms, and they thought like what to do in that case. So they and S did not have this capability of implementing algorithm. Okay, so what they did is started developing a uh, they started developing a tool, and ultimately that ended up the development of R. Okay, this is the brief history. So it came from New Zealand. The developer of this R is two statistician. Okay, and they found it. So now just see the usage trend. This is what I was talking about, a brief history. If I see, so it started from 1990s. Okay, so earlier in 1990s and 1995 it was S that was being used. Okay, see here, till 1995 there was no evidence, and there was no like uses of R. Okay, but post 1996, 1997, okay, R came into picture. See this arrow. Okay, and once it came to picture, and it started, it has no like no drawbacks. Okay, it went on increasing, and this is what we see today. Okay, everyone is behind like our programming. Okay, our servers, everything. So this is a brief history, and this basically encourages us, okay, and to learn R, to explore R. R is a R as a software is very matured now. Okay, and the reason is it has a very strong community. Okay, so in today's generation, if you talk about any software, the success of that depends on how strong the community is. Okay, so what do I mean? A community is like how many people are backing up R, so how many people are doing research on R and writing codes and making it open source? Okay, that is how the program or the language uh, wins over the other programming language. Okay, that is one thing. Second thing is you must be knowing by now that R is an open source application. Okay, so how do you assure that? So the reason is, see, there was you wanted to use R and you directly downloaded and installed in your system. Okay, there's no paid thing, there's no subscription thing, and there's no licensing. Okay, so that is the thing. That is why it is called open source. It's free of use, free for use, and everyone and anyone who wants to use it, they can directly install, download, and install it. Correct. So that is the beauty of R. So that is another reason why R is so famous. So these two are the core reason. Like it's community, okay, big community, and the open source nature of it. So these two are the things that is the reason why R is being so famous. Okay, and that is why it is used so widely. Fine. So let's move ahead. So now uh, I'll just take you through bits, some some small details of R as a tool. You must be having this. Okay, so let me open a new sheet. Okay, now this is what you have in the system. Okay, when you open, this is R Studio. Okay, and if you just open R, I'll just type R, and R looks like this. This is my R. So you must have experienced this as well. Okay, because once you install only R, so that means you are getting this application, right? Just correct me if I'm going fast, or you want to reiterate something. Okay, I'll love to take you through again. Fine. So this is R application. Once you install R, that 76 MB of file, and you install it in the system. So this is how it looks. So here you write code. I'll make it small to compare it with other thing. Okay. So this is very interpretable. I mean, what I mean by interpretable is you write code here. Okay. You write simple code here, 2 plus 2. Okay. And enter. You get answer here itself. 2 plus 2 is equal to 4. Similarly, you write any, like you want to implement any advanced algorithm. Okay, you want to do any functional programming. Okay, whatever you want to do, you write your code here and you get the output. So for example, let's say I write print and then hello. Okay, so sorry, I forgot to give hello. Okay, so I wrote print hello and I got the output hello. Fine. So and then anything you write, you want to find the function a value of sine 90, you get the value of sine 90. Okay, so the thing is, what I mean is, this is again doing the same thing. Yeah, so what I mean is, uh, this tool is doing the same thing. Like this is perfectly fine. I mean, like, but this is perfectly fine. Uh, let's start from here. Okay, so this is, first of all, I forgot about everything. Okay, I minimize my R Studio and I open just R to start with. Okay, how I'll open, I'll go to R. This must, once you have installed R, okay, this must be some icon like this must be visible in your desktop. Okay, just make sure. So once you have this, that means you have R. So you open this, double click it, and you get something like this. A small, yeah, you'll get something like this. Okay, a small window application. Okay, which has some buttons, and it will be written R console here. Okay, and you have some buttons here. So this is nothing but R application. Okay, now how do you test it? What it does? So its capability is huge. Let's start with the basic. You just type 2 plus 2 here. Okay, and press enter. You get 4 as a output. Okay, so similarly, this is mathematical. Now let's check non-mathematical operation. I write hello. Hey, good morning. Okay, and press enter. So it gives me output of good morning. Okay, so what you see here, this tool is performing good. Now I check some advanced mathematical operation. I write sine 90. Okay, and press enter. So I get the value. Correct. So what it does is it has a interface, a very simple interface. I don't know if you have any other programming background. If not, so interface is something which with which a user interacts. Okay, user as you and me. Okay, since we program, we solve problems. Okay, so we interact with this computer using some interface. Okay, so this thing what you are seeing, R console, is an interface. Okay, and what this provides is it has a simple one pager interface where you give an input. This is my input, 5 4 plus 5. This is my input. Okay, I'm done with my input. Now I want to see the output. So once you enter, okay, this goes to the application. R processes it. Okay, it uses the computation power of the laptop or the system, and it gives you the output of 9. Okay, it's a very simple thing. So all my interaction is not with the computer. I'm not going inside the computer or like opening any like command prompt and coding. So I'm simply using R console as an interface to solve my problem. Okay, so this is called your R console, and this is your user interface. But there's some problem with it. Okay, so since I'm writing a simple one liner or two liner, it's fine. But generally, when you go ahead, okay, and you start with like much more complicated stuffs, so you have to write multiple lines of codes. Okay, multiple lines of codes, and you'll have to access different applications. R is a standalone application. It's a standalone single application, but there are many other things which you need data. Okay, you need to connect it to different websites as well. Let's say you need to connect it to Facebook to pull the comments and likes of a status, okay, of your status, and then analyze it. Okay, so you have to connect with the world. Okay, and connecting to the world with only R console, only this application, will be little difficult. Okay, because it does not have that capabilities. Okay, so initially when the R was developed, so for around 6 to 7 years, okay, at least, I'll just tell you here, at least till the time here 2004 2003, it was being used. R console was used very widely. Okay, but when it took a pickup, okay, when the uses of it and the demand of it got accelerated, okay, then people analyzed, or like they felt that they should uh, have some good interface that should sit on top of R. Okay, so that will give a good experience to the user. And then they came up with the idea of R Studio. Okay, so R Studio is the thing, guys. Okay, it's not a rocket science. It's just an application. It's just a user interface that sits on top of R. Okay, I hope I'm clear to you. I'll repeat once again. So now this is a very widely asked question. If you are facing an interview or something, what is the difference between R and R Studio? Okay, so this is just a tricky question to confuse you. because you as a like as a student or as a like beginner, you'll never interact with R Studio because the days are gone. Okay, where people learn R programming in R console. Okay, no, they directly start using R Studio, but having a good background of it will always help you. Okay, so R is a application, okay, where all processing, all computation happens. Okay, and R Studio is nothing but a interface that sits on top of R console or R application. That is it. Now, if I open R Studio, okay, this is my R Studio. So now same thing. If I compare it with the earlier thing which we saw, I do the same thing. I write 2 plus 2, okay, and enter. I'll not enter here. I'll write, see here, you have a button called run. Okay, that means this can be used to execute the code. So just run it. So you don't get the output here. This has a decent console for output. Okay, so you get the output here. Okay, then again you come back and you write sign 90, and it gives you intelligence as well. See here, what is SIN? You press tab, so you get all the options here. Okay, fine. So write sign 90 and run things, so you get output here. So basically what I mean is, so there are a separate console for writing code. You can write big chunk of code here, and you can expect your output in a decent way here. Okay, so that this is separated now. Fine. So this is one thing. Now there are other two things as well. You see environment is empty, and some uh, things here which is like a little bit complicated, which might it seems little complicated to you, but no worries, we'll go through it. Okay, so that is it. So now once I'm writing sign 90 or any codes here, it is basically going at the back. It is using R console, means R application, doing the computation and giving you output here. As simple as that. Okay, now, so R Studio, if I start studying R Studio, so R Studio is divided into, by default it is divided into 4 quadrants. Okay, so we call this as a first quadrant. Let's just check on the mouse. I'm hovering the mouse. This is called first quadrant. Okay, this is called second quadrant. Okay, this is called third quadrant, and this is called fourth quadrant. Guys, clear? Okay, now first quadrant is more of a history. Okay, history and environment. Great. Yeah. Is it possible to use R Studio without installing R? No. Yeah. So good question. Okay. Which now if I ask you, if I tell you, okay, you just I would have told you directly install R Studio and we'll start the session. Okay. So there's a question. Is it possible to use R Studio without installing R? Okay. Now, just think about it. I would have directly told you yesterday, guys, there's a link for R Studio. You install it and use it. We'll start using it from today's session. Okay, but no, I asked you to first install R. Okay, then I told you install R Studio, and then we'll be able to use it. So the reason is R Studio alone is nothing. It's just a UI that needs. So basically, it needs as an input called R Studio, R. Okay, so it is not possible to use R Studio alone. Okay, for doing the stuffs. No, it's not possible. Okay, rather, yeah. At the same time, if you want to use only R, that is possible. You can use that, but R Studio alone is not possible. Okay, Vishal, am I clear? Fine. So let's move ahead. So we were talking about quadrants. Yeah. We'll come to it. Okay, we'll come to the questions. Now we'll see the first quadrant. So as we see here, There are four quadrants. This is called first quadrant. Okay, this first window, you can say first window or first quadrant, second quadrant, third quadrant, and the fourth quadrant. Okay, fine. So see here, we'll come to it. First quadrant is basically all environmental and historical stuff. So what it is you do any activity, okay, in your R studio, whether writing code, installing things, downloading things, giving output. Okay, so it is all tracked here. Okay, the history. See here, I have written two codes. Okay, it has the record. So that is basically in R studio, you have a provision of tracking things. Okay, and it is, believe me guys, sometimes it is very helpful. You write n number of lines in a real time, like when you start working, you write codes and you forget what you did. You got the output, but you are not able to reiterate and trace it what you did. Okay, so in that case, our history and environment comes to picture. It really act as a like escape. Okay, it will help you a lot. So you can track it, whatever code you have written. Now environment is, if I create any variable. Okay, let's say I created variable called x and I assigned it a value of 10. Okay, and I run it. So see here, 10 is x is having a value of 10. Okay, if I just click on x and run it, so I get an output of 10. Okay, but if I want to see the details of it, so you can see it in environment. So here our environment shows that x is a variable and it has a value of 10. So likewise, n number of variable you can create here. You create a variable y and assign a value of 20 here. Okay, and run it. So you get a variable y with a value of 20. So it tracks all the variable that you create. It tracks all the functions that you do. Okay, it tracks everything. It has all the things that is being used in session. Okay, now this was first quadrant. Now coming to the second quadrant. Second quadrant is a place where you write a code, as simple as that. Okay, this is the editor. Okay, if you are aware of any editor, notepad editor, or any like SAS editor, if you have learned SAS. Okay, uh, Python editor, if you did Python, so you do labs, right? In labs you do strata, so there is some editor. So likewise you have one editor in R, and this is the editor panel. This thing what you are writing here, the second quadrant, is your editor panel. Okay, now coming to third, this is called console. So I can increase or decrease the size. Okay, this is called console. And the beauty of this is used for dual purpose. Here you get the output, whatever code you write and run. Once you execute it, okay, the output or the executed code along with the output will be visible in the console. Okay, so this is probably R Studio, you can say, R software. This alone act as a R software. If I maximize this, now I can use this as a R. Okay, now the best part I'll tell you. If you meet people like some experienced professors and like other people who have been working in R from past 10 years or 8 years, they that only use R console. This part, okay, because this act as a R software. You get the output here, and even you can write code here. Let's say if I want to write code, I have to write tan 45. Okay, I write tan 45 here. Okay, I press enter, so I get the output. So this is nothing but a R. Okay, it has a dual purpose. You can write code, you can, okay, and you can even, if you, sorry again, yeah, you just need to give code here. Okay, and press enter, so you write code and you get the output. Sorry, 1 minute, I'm getting some messages. Okay, fine, so let me increase the volume if that is the case, and I'll be a bit little louder. Okay, perfect. Yeah, yeah. So we'll come to that now. So this is fine, right? So this particular console, the third quadrant, act as a R software. Okay, you can write code here as well as you can get the output. Everything is done here. So thing is, like, let's say I write a code, write anything, not like a create variable or not. You write x, create x and y. Okay, you run it. Okay, once you run it, you get the codes here. Okay, and you even get the output. If I want to see what is the value of y, okay, I get a output here itself. See here, 20 is output in the console. So probably this is more or less like a R application. Okay, now coming, like, let's repeat once again. There's one doubt in the environment. So this environment is, guys, this environment is actually used as a, you can say it is used as a repository, okay, of all your activities. Whatever activity you do, it will get tracked here, okay, in the environment section. And history is basically tracking your history. Whatever you do, see, till now I've written so many codes. Okay, it has everything here. Okay, and in among this, there are something which just gives the output, like 1045 will just give you output. Okay, but there are some activities that will create a variable. Okay, so all the variable creation part will come in the as a uh, value in the environment. Okay, these are the only difference. Okay, so done with first, second, third quadrant. Coming to the fourth quadrant, fourth quadrant is basically your app store or your Android, right? Android store. So this is that. Okay, in R alone. Yeah, we'll come to the command, guys. We'll come to the command. Don't This thing is like, we'll see in details. Okay, so leave it for now. Okay, now talking about the fourth quadrant. Okay, so fourth quadrant is your app store. Okay, your app store, Android Play Store. R, as I said, the challenge with our application was, it was not we were not able to connect to the world. Okay, but R Studio have enabled that capabilities. Okay, and you can connect your R with anything. You can connect it with Facebook, you can connect it with Twitter. Okay, you can connect with some any particular website. Okay, and start interacting with it. So this particular section, the fourth section, is that. Okay, so you will get to uh, do anything. Okay, now uh, see packages. Okay, R is, like, let's say, let's start with a good example of a smartphone. Okay, if I give you a smartphone without any internet. Okay, is it will you be able to leverage the capabilities of a smartphone with that? No, not at all, right? So same thing is here, because in smartphones, alone is used for nothing. It will just be used for calling and like calling someone, receiving calls, or probably maximum you can do is like you can do SMS. Okay, okay, but once you have internet, you have apps. Okay, you have different functionality, and for each functionality you have different apps. Okay, so that apps is enriching or enhancing the capabilities of your smartphone. Similarly, R, R Studio or R alone will not be able to do anything apart from some basic calculations and mathematical operation. That is it. But if you want to leverage the advanced capabilities of R Studio, you need to have some packages. Okay, packages is nothing but, you can say, application, the apps that you download. Okay, you want to do some you want to perform some operation. Okay, just go to Google, search for the related package. Okay, let's say I want to connect my R with Twitter. So just connect R with Twitter. Okay, and you get a link which will tell you install this package. See here, just scroll down, and I'm just giving you an example. Don't just to illustrate the use of that fourth quadrant, but we have the details of it. Okay, so they are telling you steps. Now, get Twitter Oath is one application you need to install. Okay, they have given the link as well, and you you can install it. So what you will do is you'll go back, you'll go to package section. Yeah, you see the packages, okay, and then you can click on install, search for the package and install it. Okay, just a brief of it. We'll see the in details when we start using it. But let's say you need to install Twitter R, TWI. So this is basically Twitter R. So this is one application that will help you to connect R with uh, Twitter. Okay. Now, if you want to do something with Facebook, so Facebook S4. Okay, this is application which you need to install. Okay, if you want to do something with LinkedIn, okay, so you need to install yeah, linked matrix or linked IM. So definitely there are, if you want to do something with Amazon, okay, just search for Amazon. It does not have uh, okay, so likewise you'll have to search and you can do it. Okay, so this is what, and then this is a package, and that package comes and sits here. Okay, and you need to select that whichever package you want to use. Let's say I want to use AWS. This is Amazon Web Services. I just check it. Okay, and let's say I am using some simple application like data sets. I check and uncheck it. If I check it, so I can start using it. Okay, now coming to plots. So if you plot anything, if you plot any graphs and all, so you can see here. Okay, now this is a basic overview of all the four quadrants. Now coming to a point where people or no, any person can say, I am not aware of any coding, okay, and I don't know what is R, but I want to start working in R. So for that reason only R is meant, R Studio is meant, and it has made all the capabilities so easy. So if you want to do any operation, okay, and you want to start, so you can get the help from R Studio also. So there's a way, like let's say I want to know what is print. uh, I want to know what is print function. I don't know. So what R does is just write a whatever you want to search, okay, whichever function you want to know in detail, just write question mark and that function name, okay, and enter. Just enter it. Okay, enter means I run it, run the application. So once you run this, so you'll get help here. This is a help section. So this is the third point, okay, which for which R is so famous. R is very well documented. So if you compare it with any other open source application, R is very well documented. So if you are a very newbie and you want to do something, you want to learn R, so this is the best point to start. Question mark and your concerns, what you want to learn in R. You will get a document, and this is very well documented, and just read it, and you'll be able to figure out, yeah, what is print and how to use print. Okay, with if you scroll down, you get a sample codes here. There are so many sample codes. Okay, just copy this and try and execute it. It will run, and you'll be able to understand. I'll just copy this and paste it here. Okay, and if you run this, you'll start getting output. Okay, I'll not run it now because it will be confusing, okay, for you. Fine. So likewise, just one question mark is querying the R documents. Okay, there's a defined R document. It is querying from there. Okay, but let's say you are not even satisfied with this. You are not clear, and you still have doubts. Okay, so then what you do is you do a double question mark. Okay, so double question mark will search from the web. This search came in from the R documentation. The second question mark you add and run it, that will come from the web. So just run it. Okay, see one small R means red bubble popped in. That means it's a search button. Okay, and then see you got related documents from Google. This is a web search, and then you can click any one of them which makes sense to you. You have PDF of that, you have source code for that. Okay, So different forms of explanation. If you want to know if you want to understand, read something rather than executing, you can see the PDF. If you want to execute something, you want some code, so you can use this, and likewise. So this is the capability of help. So this is, every now and then I'll be using it, okay, to show you different abilities and capabilities. Okay, so I'll take you through. We'll be using a lot this help section because this is very, very helpful. And you should also bring this in your habit, okay, of using like question mark. Now, fine. So let's take up a question now. If you have any questions, let's start with the question. So the question is, what is the difference between second and third quadrant? So second quadrant is your editor. It's full on editor. Okay. If you have some experience in any programming language, or let's say a notepad. What is notepad? Notepad is an editor. Notepad plus plus is again an editor. Okay, so it's a second quadrant is your editor. You just need to write stuffs. So all the input that will be coming from the programmer or the data scientist or the user, okay, it will come in the second quadrant. Okay, because you are the one who will interact with second quadrant. Now coming to third quadrant. Third quadrant is nothing but R. You know R, which I showed you at the very beginning. You give a output, you give a input, okay, you give a input, and you run it, enter it, you get output. Okay, so any like you write tan 45, okay, and you run it, so you get output. So this is your R application. Okay, now what generally what we use is we write in editor, we run the code or execute the code in editor, okay, and we see the output in console. This is a general purpose. Okay, this is the only difference. Fine. Now yeah, Rashmi, which part you want me to repeat? Yeah. So there's one question. What is like the operator which we are using right here? This operator, less than and then dash. Yeah, this is this operator. Now what is this? So guys, this is a assignment operator. Okay, this we call it as a assignment operator. Just let me ASSIGN assignment operator. Okay, now how will we use it? You know what is equal to sign? Equal to sign. 2 equal to 2. Okay, now this, what does this mean? 2 equal to 2. This is like I'm comparing it, right? X with y. X is equal to y, right? So this is comparison. Okay, now what is double equal to? This is in mathematics it is a comparison, right? You compare 2 with 2, but in R it is little different. What it is assigning 2 with 2. So if I'm writing x is equal to 2, that means I'm assigning 2 value of 2 with 2x. Okay, and this is same. Just I'll be using it either one very frequently, but the use of this 2 is same. X is equal to 2 and x less than uh, dash 2 is same. Okay, they are used for the same purpose. And as R is like to make it little different from mathematics, like we generally use equal to in maths to compare two operators. So I generally use it's a person to person thing. Either you can use x y is equal to 2 in your regular thing, or you can even use y is equal to 2. So now I'll show you an example. Y is equal to 3. So if I run this code, a value of 2 will be assigned to y. See here, run, and you see y is equal to 2. Okay, now if I run this, y is equal to 3, or let's say z is equal to 3, I run this, so a value of z is equal to 3 is assigned. So that means both the operator are working in the for the same reason, like the use of it is same. Okay, but the just like how do you want to represent it? Okay, they are doing the same job, they are doing assignment, but now don't get confused with z is equal to 3. This is different. Okay, and we'll see this. Fine. I guess I'm clear on this. Yeah. So this session and computation, it holds a very like you. It's very important. Okay, to understand for you all your initial days learning. Okay, so why I'm telling you, computation is something which uses your computer power. Okay, from that computer it came. You got the term computation. Okay, so let's say we are 100 people here, and yeah, 101 people here, and we all have systems. Some of them are you having 2 GB of RAM, someone is having a 4 GB of RAM, someone is having 8 GB of RAM. Okay, someone is using like Windows OS, someone is using Mac, someone is using Linux. Okay, so this is the specific configuration of a system. Okay, and in that particular system you have R installed. Okay, so R is using that particular system or the resource of that system. Okay, are you clear with this? Right, you must be clear. Okay, R is installed in a system, your personal laptops, and your laptop is having different configuration. You have different OS, you have different hard disk, you have different size of RAM. Okay, now based on that configuration what you have, R is the speed of R depends. Okay, R is a software that uses RAM. Just take a point, guys, this is very important in terms of, again, from interview perspective. R is a software. R uses RAM. Okay, unlike any other application which works in which does not uses RAM, R uses RAM, and that is the reason it is called in memory application. In memory application. Okay, so there will be a question you will be seeing very frequently: what is in memory? Why R is called in memory application? Okay, the answer to it is R is called in memory application because it uses RAM. Okay, now so RAM is fine. Okay, now if you see why it varies from system to system. Let's say I am having 8 GB of RAM or 16 GB of RAM, and you are having 2 GB of RAM. Okay, so if it uses RAM for its computation, all the processing. Let's say I did sine 90 into 10,000 times. 10,000 times. Okay, so this definitely needs memory, right? And it gives the output. So if I have around 2 GB of RAM, so it will take again the same memory, but the resources will be less. So it will be it will be performing in a less speed. Okay, so the speed of R depends on what is the RAM you are having. Okay, so that is why it is a RAM specific application, and you need to have a, if you want to do a very large computation, I mean, like you want to work with 3 GB or 4 GB of data. Okay, big data, then definitely you need to have a good RAM size. Okay, and that is what you mean by the R performance, R computation performance. That is directly mapping, it is directly mapped to the RAM of your system. Fine, that is one thing. Now coming to session. Session is something, like just related with like you opened one any web application. Recommended RAM is anything. Okay, since you are learning, 2 GB or 4 GB will work out. Okay, but if you start doing some projects or real-time projects, so that in that case you might face some issue. But yeah, 4 GB is decent enough to work to start with. Okay, now session is let's continue with the session. Session is something you open. Let's say you opened Facebook. Okay, you did some activities there. Okay, then you closed it. So what you did actually, you opened a session. Okay, you used it. Okay, you did whatever you wanted, then you closed it. So once you close the browser, your session is closed. Okay, so you Facebook is no more sending you what updates from your friends uh, on your wall. Okay, it is not sending you any messages or notification. Okay, but the moment you open it again, it will all the information will be bombarded to you, or you'll have all the updates from your friends and things in your wall. You'll have notifications, so that is called session. Okay, same thing is used here. Okay, when you open your R and you work in an editor, so this is your active session. Your editor, this is your active session, and you'll have to do all the activities here. Once you close this session gets closed. Once you open it, this session again become active. Okay. Now what you have to keep in mind is, since as I said, you need to install all the packages and you need to do all the activities here. Okay. So the importance of this environment comes there. You create a variable. Okay. You create variable y, you create variable x, and you put it here. Okay. So what you do is, this is basically you create a variable x for this session, this particular editor. Okay, if I want to name it, I want to let's say I want to save it. I save it in a desktop, uh, first session. Okay, and I save it. Then I close this. I close this. I did the activities. My this variable is created. Okay, and I open a new one. Okay, and I close this. Let's say I'm not closing, but I open it, but this will be also be there. This will be there. Okay, so this is very session specific. Okay, you install any packages. Let's say I install any package.
Sir, please repeat.
Okay, 1 minute. I'll repeat it, no issues. So I install any packages. Let's say I install Plyr, PLYR, and install it. So all these activities which I'm doing is getting tracked in a session. Okay, and I can use it in a session. So what you need to keep in mind is, don't make it so complicated. It is very simple. You open R, you do all your activities, you save it. Okay, once I save it, so once again I come back, so everything will be there as it is. Nothing will be lost. So if you shut down your system, you close your system. Okay, you close it, you shut down your system got abruptly closed. Okay, that does not matter a lot. Anytime, everything will be stored, because it is this R Studio has this capability of storing the session. So once you open it again, after you reboot your system, you open your R again, you will see everything is in place, nothing is lost. That is the beauty of the session. Okay, guys, I hope I'm clear. If I'm trying to relate things with a real life thing, like which we interact on a day-to-day basis, so that you become familiar with it. Okay, so take a good example again. You open Facebook. Okay, you wrote something in a status, or you messaged someone. Okay, or you liked something, and you closed it. Your system got closed. Again, you open it. Did that page you liked, or the notification you created, or whatever you posted gets lost somewhere? No, right? It stays in a place. Similarly, if you do some activity here, okay, and you save it, I mean, like, you saved it and then you started doing your activity. So how do we save it? Okay, so you open an editor. Let's say I open an editor, I do some activity here. Hi, this is Sajid. Okay, I do some activity here, and I press Control Save. Okay, and or I go to File, Save As. Okay, just give the name of the file. Let's say my name. Okay, and then save it. So once you save it, so it will be saved. See here, it is saved. I saved it first session.r. So it will be saved, and the extension of that file will be .r. Just keep this thing in mind. Any file that you see with the extension of .r is a R file. It will only open in R, nowhere else. Okay. So if I want to open this, I can, if I have R Studio installed in my system, I directly double click it. It will be opened here in my. But if I don't have, so I'll not be able to open. If I don't have R installed, it will never open there. That is how we save it. Now, this is one editor. If I want to open a new editor, okay, I'll go to File, New File, R Script. Okay, this will open a new editor. See, this is a new editor for me. Hey. Okay, now if I don't use this hovering file and all that, there is a shortcut for it. Control Shift N. Control Shift N. This will open a new editor. That is it. Okay, I just keep on closing unwanted editors. I don't want to save this. I again close this as well. Don't want to save it. Fine, this is my first session. Guys, clear so far? Yeah, saving a session, Control S. Jennifer, you this question is like how to save a session. So you cannot see a physical session is getting saved. You just save your file. Press on Control S. Okay, great. Chalo then. Fine. Anything else? We can start with the questions. Okay. So now there's a code which I'm writing here. Okay. This x takes the value of 10. Okay. Then again I'm writing a value of y takes the value of 20. Okay. So this is a code. I can execute it. Control enter. I'm getting the output here. See here. I'm getting the output. I get the value of x is 10. Okay, if I want to write something which is for my help, okay, which is for better understanding of the code, okay, and that is called comments. People generally, when you start writing, right, when you start writing codes, so you write lots of comments, okay, and why is that comment written? That the sole idea of that comment is to, when you come back 1 week or 1 month later on and open the same code, you should be in a position to understand it, right? Otherwise, again, you'll have to use all your brains and to execute and like decode it. Okay, to avoid such things, people generally write lots of comments. Okay, and how do we write comments in R? Is we just give a hash. Okay, hash, and my name is, let's say my name is something. Okay, I'm creating a variable called y for some reason. I'm creating a variable called y for some reason, right? So I wrote this. The reason can be anything. Okay, and you run this code. When you come back and you see, yeah, I created the variable y for this reason. Okay, so it is there in your mind. You save it and it will come as it is. Now, comment is something which does not get executed. So you just click on that line, okay, and press Control Enter. It will never get executed. See, there's no changes here. But at the same time, you just press on y will get executed. Okay, this is not, R assumes that this is not a code, this is not executable code, this is the normal text or anything. It can be digits as well, no issues, but it is not executable. It is used for self, like help, I can say self assistance. Okay, so just build this habit since it's from very scratch we are starting. Okay, so let's take all the best practices in consideration and start the blocks. Okay, guys, I don't know for what reason, but yeah, so this second and third quadrant is creating confusion. So second quadrant and third quadrant is our application, the R which we saw. It is called console. It is used for displaying the output. I mean, see, for example, I write some code here and I want to see the value of x. So where this entire activity is getting displayed in your console here. Okay, you write things here, you do some activities here, and that is getting displayed here. That is it. So second quadrant is your editor. Okay, and the best example which I can give you is Notepad is one editor. Okay, for me, you have this editor. It is very helpful. Notes, I write things here. My name to remember whenever I forget. Okay, my address, right? Now this is a notepad, but this is an editor. I write things. But if I do the same thing in R, if I want to write something, where will I do it? I will have to do it here in this editor. This is the second quadrant. Okay, this comes with the added advantage, added feature of executing it. Okay, once you execute it, the third quadrant comes into picture. It is the only place where you can see the output. In R Studio, third quadrant is the only place where you will be able to see the output, and nowhere else you can see the output. Rather, right, you can write it in a different place. If you want, you can write it here. Okay, you can write here, but cannot see the output. Here, output is seen only in the third quadrant. So this is the only difference. So in a one-liner, second quadrant is an editor where you write code where the user interacts. Okay, third quadrant is a place.
So what is the difference between the first and the third quadrant?
First and so why? Fine. First and a third quadrant, like this is something. You can the difference is resembled in the screen itself. Okay. First quadrant is all about tracing the all environment and histories. Third quadrant is all about your outputs. Okay, output is getting displayed here. It is now if I do sine 90, just see that first quadrant and third quadrant. No variable will be created in the first quadrant. Okay, see here. Do we see any variable here? No, because I have not created any variable. So all the creation marks a place in environment. Okay, and all the thing which you see here is all the output is displayed in the third quadrant. But at the same time, if I want to assign a value, let's say a to sine 90, okay, and then I run it. So then I see, yeah,
thank you, sir.
A variable called a is created. So all the creation comes into first quadrant, all the output comes into third quadrant, all the editing, all the text that you input comes in the first quadrant. That is it, as simple as that. Fine, so let's take the question again. Yeah, you can write. So the question is, can we directly write a command in the third quadrant? Yeah, you can write, definitely, and which we have seen as well. Okay. Fine. So I guess we are good to we are good with the basics. Okay. So we know what is our software. We are familiar with it now, and we know what is different parts of R Studio, different quadrants, and what is the applicability of that. Okay. We saw some basic commands, which was very basic, and we saw how to take help of from R. Okay, then going back to our slides, let's see if we have anything there, anything is interesting. Then we can take things from there. Otherwise, we'll start with the codes. Okay, so we have seen the trends, we have seen the growth. Yeah, we saw the three reasons why R is so famous. First is open source. Second is community. Yeah, I'll turn that off. I'm also getting annoyed with that. Basically, there's some setting changes for which I need to reconnect. I don't want to reconnect again. From tomorrow's onward, we'll figure it out. Yeah, thanks. Yeah, so yeah, this is the trend, okay, which we saw, and since someone took the name of Stata, right? So see where Stata stands and where R stands in today's time. Okay, it is far ahead than Stata and any software for that matter. Okay, you talk about. See, this is a comparison of R with other similar statistical tools. So R is a statistical tool. Okay, multi-purpose statistical tool. Since statistics is not only limited to finance or some particular field, it is used in everywhere. So the application which is shown here, SAS, SPSS, S plus, from which R came in, okay, and Stata, these are the competitors. Okay, but R is way ahead than other applications. So that is it. And then you see R as a means popularity as a programming language. Okay, this is a little old data. I guess it's 3 to 4 years back. Okay, but still it has increased a lot. It's increased a lot now. But if you see it, so R and SQL, which this is the two language that is a agenda for our session. Okay, these are the most like two popular languages that we have in an industry. Okay, and this is one of the language that if you have a good grip of it, okay, you can crack an interview, you can get a job very easily. Okay, it becomes very easily. Then this is a comparison. Then number of blogs. See here, the reason which why I told you why R is so famous. First point which I told you is community. It has a very good community. Okay, and the second was it is open source, and third one is it is very well documented. These are the 3 points. So justify the first point. R has 365 blogs. I mean 365 different blogs. Okay, now just to state a good example. Okay, so let's say you are doing some work. Okay, and you are, let's say you are working on you want to implement uh, sentiment analysis in R. Okay, you want to analyze the sentiment of a people of Kolkata, how they are behaving, how they are liking this winter. Okay, so I'll go to let's say the first thing, the very basic thing which I go. This is just an example. Don't take it literally as an implementation. Okay, this is an advanced topic which we'll see, which might we see. So let's say I want to see hashtag Kolkata. What people are talking about Kolkata. Okay, so there are many things. Okay, so then are about discovered whatever, like then people are talking about like some lovely winter morning in Kolkata and some activities that is going around in and around Kolkata. Okay, so Victoria and all that. If I want to make, there is some performance of Arijit. Okay, and I want to analyze this. Okay, so I want to pull out all the tweets from Twitter, analyze it with and analyze whether people are talking positive, negative, happy, sad. Okay, and how they're feeling about Kolkata. So I'll just, what I'll do is do sentiment, like sentiment analysis in Twitter. Sentiment in R. Okay, using Twitter data. Just Google it, Twitter data, and you get a exact code here. Okay, so there are many blogs. You'll see medium.com. Step Up Analytics is one portal which is growing as a R blogs. Okay, you get GitHub repositories, R blogger. Just click it and you get the entire code. Okay, so that code is not at all a problem in R. At least in R, code will not be a problem for you, that you are sitting and struggling in writing codes. Okay, that will never happen. Yeah, so what you will struggle in is what logic you should implement. The logic, if you have the logic, you have the code here. Okay, just copy it, implement it in R. Okay, so this is the beauty of R, like open source base. Okay, community base. So there are many people who are supporting R. They will come and write, like people like you and me who are like very enthusiastic and called R enthusiasts. They write stuffs that will help other people. Okay, so that is what how community is built up. Okay, fine. So that being said, let's move ahead and see what else we have. We have seen the community, and there are other stuffs. Statistical. This explains the tool. Okay, what we have seen R. Okay, and R Studio, it explains the tool. Okay, so I'll share the slides. Just go through the slides. Okay, and then we can you can understand if anything is that is you don't understand. Just point me out next session. I'll take that. Yeah. So let's see the drawbacks. So drawbacks indirectly we have already discussed. Okay, and the drawback is more or less the size. Okay, so in today's time, since the world is getting digitized, okay, and everything is in a mobile phone and everything is in form of digital, the size of the data has increased enormously. Okay, and we have to agree on this part, and this is a challenge, right? So the data size is a bottleneck here, and since R is a RAM based application, in memory application, it depends on the RAM size for its performance. Okay, let's say I have a RAM of 16 GB in my system. Okay, and I generally deal with a data size of 50 GB, 55 GB. That is again a very big problem for me, and my system gets heaten up. Okay, so what I do is like I break the data and then I upload it in R. Okay, so if you do computation on a very big data set, you should have a very good RAM in a practical scenario. So that is a drawback, computation power. Okay, otherwise if you have a small data set, R is fastest as compared to other application. Okay, and a second and the advantage is that for everything that you think of, okay, whether it be you want to implement some trigonometric functions, okay, you want to create your own econometrics calculation or equation, okay, for that you have one package in R. Okay, so let me just take you through, before we go ahead, let me take you through the app store of so-called app store of R, and that's called CRAN. Okay, CRAN is called some archive network, R archive network. Oh, let me see the full form of CRAN. Okay, it is called CRAN packages repository will be referred as comprehensive R archive network. It's called comprehensive R archive network. It's a store where you have all the packages. Okay, it's kind of app store where you have all the packages. Fine. And when we this is a CRAN, it's kind of app store. Just keep this thing in mind. Okay. Now, whenever we communicate, we uh, we install package. Okay. Whenever we try to install any package, let's say I want to install LM. Let's say I want to install k-means. Okay. Or let's say some simple package called hmm, what should I install? dplyr. Again, I install. Okay, that time I install dplyr. I install it. Okay, so once I install this, so this dplyr is coming from where? It should be coming from somewhere, right? It is coming from your CRAN. So this R is automatically getting connected with CRAN. Okay, and it links with it, like your mobile is connected with App Store. This R is connected with CRAN, and the application comes from here. Okay, fine. Yeah, so this is the beauty, and all the application is created, everyone is creating an application and storing it in CRAN. Okay, and for your information, uh, like there are people who have CRAN access, okay, who are admin to CRAN, who approves the package. Yeah, this package is good or bad. Okay, should it be available to the public or not? So there are many people, a few people actually, who have this responsibility. And in India, there's only one people who is like he's from ISI Kolkata. He has that access. Okay, some boss, I don't know the exact name. So he's having that privilege. Fine. Okay, so we saw CRAN, we saw the package installation, and what else? So let's move ahead and start with our introduction. Okay, so yeah, so we'll start with the very basic things. Okay, and that will be probably your what are the basic codes that we write. Okay, the operators. So for any programming language you talk about, they have some data types. Data types is like how do they interpret the inputs from the user. Okay, now if I enter one, I enter a, I will enter ABC, I enter 1 2 3, so it should be interpretable to the tool what it is. Okay, so that is called data types. So in R we have very limited data types, and that is why it is so simple. Okay, we just need to understand that 3 to 4 or maximum 5 data types, that is called integer, which takes int value. Okay, 1 to 3. There's come character or string that takes all alphabetical values. Okay, there's something called list. Okay, which takes like series of values. Okay, there's called something called array, matrix, and the most important of all of them is that we use on a regular basis in our day-to-day life is a data frame. Okay, so these are the list of data types that we have in R. So let me just list down for you. Okay, so we have integer. First is integer. Okay, second is your character, char. Okay, third is your called string, or that can be referred as character only. Okay, then you can, the different one which you can think of is list. Okay, and the fourth one I'm categorizing it in a way which we'll see is most widely used. Okay, list, and and the fourth one which is very important is data frame. And this is int character list array, you'll find it in all the programming languages. Okay, but data frame is something which is very specific and is confined to R. Okay, it's a feature of R. So if someone asks you what is data frame and from which tool it is associated with, so you can directly say our data frame is a core feature of R. So whatever data you import, okay, whatever data you import, that ultimately we'll have to deal with data frame data types. Okay, we'll see what is data frame. No issue, no, not to worry. But just understand the term. Okay, we have integer, we have character, we have list, and data frames. Okay, now let's move ahead. Okay, let's declare a variable again. I'll clear all the session, the environment. Okay, so let's create a variable called x. I created x is equal to 10. Okay, now 10 I've created. I'll just run this. The value of x is created. Now I want to see what the value x. Okay, the value is 10. Okay, now if I want to see what type it is, I want to see what is the type of this x, means what data type it is. So I can simply see, I write class x. So it gives you numeric. Fine, so just see it here. Okay, it gives you numeric. So it says, yeah, it's a numeric type. Now again, if I declare another variable called, let's say I declare another variable called y, and I kept it as hello, see you. Oh, I ran that. Okay, and then I want to see what is the type of this variable y. I want to see the class y. Okay, you see character. So this R understand itself. So why I'm telling you this is very basic, but I'm trying to differentiate between other programming languages and the advantage you have when you are learning R. Okay, so it automatically detects and says it is a character. Okay, but at the same time, if you are aware of any other programming language, so there we used to declare first the type of the variable. So we used to declare it like int x is equal to 10. That means you are the person responsible to declare the type of the variable. Okay, but R has taken that out from the picture. Okay, and R says you just keep on declaring the variable. I am the one who will take the responsibility what it is. It is a character, it's integer, so it's not our pain. Okay,
Sir, can you repeat?
so this you come in between and you just pop up and say the repeat. Fine, no issue. See here, so basically I'm discussing, no issues, just yeah. So this is basically I was trying to explain what type data type is. Okay, data types. So data types in R, okay. So how many data types we have? We are seeing this. We are seeing this. Now I'm talking about any particular variable. I'm declaring variable x, okay, and I have declared a variable x as 10. Okay, if I tell you, uh, first understand how we declare a variable. We declare it by x 10. Yeah, we declare x as 10. Okay, but here we have never specified what x can be, whether it be integer, whether it be character, string. No, we have not. Yeah, so you press control enter.
Can we write x equals to 10?
Come again. Hello.
Can we write x is equals to 10?
Yeah,
Hello?
yeah,
Can we write x is equals to 10?
yeah, we can write. So see here, it's all about the habit. So I've built this habit of writing assignment operator, but you can write x is equal to 10. Okay, you put you
Thank
just
you
run
so
it. Okay, so see, x is having a value of 10. Now here I have not declared what should be the type. So see, typing is nothing but a naming, like characterizing thing. Like let's say uh, I'm a engineering guy. Okay, so you are economist. Okay, as a person, like people are same, but you we are specifying extra feature called yeah, you are economist, I'm an engineer. Okay, so same thing, this x holds a value, y also holds a value. This is like, let's say hello, see you, they both holds a value. Now if I want to see specifically what type of value x holds and what type of value y holds, okay, there comes the picture, there comes in a thing called data types. What data types it is, okay, whether it be is a integer data type, character data type, it is a string data types. Okay, is it a list, is it a data frame? So these are the types, okay, giving extra feature, added feature to it. Now if I talk about other programming language, let's say I used to write codes in Java. Okay, so now in Java what we generally do is, before writing declaring a variable, I used to write int x is equal to 10. So what I was instructing my tool or the language, that I'm declaring a variable x and it is of integer type. Okay, and it holds a value of 10. Okay, but here this declaration of integer type is removed. Okay, you just keep on declaring the variable. Okay, once you declare the variable, run it. I ran it, and if I want to see the class what it has, okay, x, so if I run this class x, I get numeric. So it says, R says that x is a numeric data type. If I want to see the class of y, then I just run this. I see y is character. Okay, now I want to see what is the size of x. Since we are dealing and working in a RAM, okay, where size and the computation power is always a bottleneck. Okay, keeping track in a long run, I'm telling you, keeping track of the size of the object or the size of variables that you create is like kind of mandate, you can say. Okay, it's compulsory. Okay, so what I will do is object size. So guys, make this habit of tab. Okay, once you write code, say, because like a coder will never be a labor. There's a very good proverb. Okay, you should not type everything, take use of intelligence. Okay, press on tabs. Okay, it will give you the intelligence. Okay, and just press enter. Object size x. So x is of size 48 bytes. Okay, now if I want just to see it how it differs, I create a assigning a variable big digits. Okay, let's say something like this, 2x, and then I check a value of x. Sorry, object size, it is same. Okay, so what it is, what comes into picture here is whether you give one digit or 100 digit. Okay, it has the same size because it allocates the same memory. So don't get into memory thing. Okay, but yeah, when it will differ, okay, when you have when you go from integer to list. Okay, when you can list is basically a combination of digits. So if I want to keep multiple digits. So that time size will increase. Okay, so object size we know, class, we know integer and string. Now let's move ahead. Okay, so the primary, you can say the basic building block, you can say cell, you can say the cell of R is a vector. Okay, vector is a very primary data types. One minute, guys. Like, tell me when we are done. Okay, because I like have to check on the timings. Yeah. Okay. So how do we declare a vector? That is important. Okay. Vector is something which you is a combination of digits, combination of integer, combination of character. Okay. What we saw here was a single digit. We declared x as a single digit. See here, we declared x as a single digit. X is equal to 10. But if I want to declare uh, x as something called 10, 20, 30 separated by comma. Okay, so this is called a series of integer, and for that you have to declare it in a pattern like this. You have to open the bracket, put the digits, close the bracket, and then start it with C. Okay, so C denotes vector, and the digits or the character which you inside the vector, that is called elements of a vector, and you run this. Okay, so now x, if you run x, so x is nothing but a series of numbers. It has a multiple numbers. See here, 10, 20, 13, something. So this is called vector. Now you must have learned vectors in mathematics as well as in physics. Okay, so vectors, what you have seen there, it is exactly the same. So it has, apart from the direction, okay, a vector has a magnitude and a direction. So you leave that direction part. Okay, just talk about the magnitude. So it is having all the vector, you can perform any vector operation here. Okay, so let's say you have vector x and you have created a vector y. Again, how to create a vector? C, and then I give a let's say 1, 2, 3, 4. Okay, let's say 4. So the vector of same size, so x is this and y is this. So let me run both of them. So I have 10, 20, 30, 40, 1, 2, 3, 4. Now you think of any vector operation. What is vector operation? X plus y. You can do it. Okay, see, the vectors are getting added. 1, 2. Okay, now vector operation, any vector operation that you think of, multiplication, addition, subtraction, power, square root, everything that you can do here. Okay. Fine. So now you created a vector. Now there are some functions that is specific to vectors, or that you will be using for a vector. Okay, and that is, what is that? That is basically, if I want to see what is the length of the vector, so I'll simply write length. Let's say length of a vector x. Okay, I want to see, so what is the length? Length is a, right? Just enter a and see 4. So it will give you how many elements it has. 4 elements. So the length of the vector becomes 4. Correct?
So instead of x is equals to c within brackets 10, 20, 30, and 40, we can use any other variable like a, b, or anything.
Where? Here? 1 minute. You mean
So
here?
in the command section,
Yeah.
command section second quadrant, x is equals to c within brackets 10, 20, 30, 40.
Yeah.
We can use any other variable instead of c.
No. C denotes vector. So that's why specifically you can change the name of the variable. You can create a is equal to c and all that. But C remains constant. C is a vector. Just try if you create.
Okay, thank you, sir.
Okay, so C is something. Is a way to declare a vector. Okay. Fine. So you got the length of a vector. Now let's move ahead. Let's see what we have. Yeah. So we have seen integer vector. Now if I see, the beauty of it is, just write class. and that vector name x or y as well. Let's say x. Okay, so you get numeric. So what it is now? R sees that what is the elements that you have inserted in a vector. So you have inserted all numerical elements. Okay, the moment you try to insert a now, and you excuse me, yeah, you can insert a. Now you see the class of a character. Okay, so it changes. Initially it was all integer, you inserted character, so character is overheaded, like you can say superseded by integer, and you get a character. Okay, the output. Now what else, like you can create a vector b, and that will be of type, let's say hello, hi. I'm trying to insert all my strings here instead of digits. Okay, or let's say fine. So sorry. So I'm trying to create uh, a vector of strings. I'll run it. Then again, I'll check the class. So here again, I'll get a class of character. Okay, because I have inserted all characters. So a vector can be integer or a character. This is what I wanted to tell you. Okay. So whenever you do some assignments, or like we start going through it, so there will be a situation where you'll have to create a integer vector. Sometimes you'll have to create a character vector. Okay. And then again, if I want to see the length of b, b is a character vector. Okay, if I want to see the length of b, okay, I just type length and then b. I get the length. It has 3 elements. So each thing, to make it very simple, each comma, okay, represents like one element. The how many comma you have? So let's see, 1, 2, 3 commas you have. You have 4 elements. Okay, and if you try and do something like this, it will be an error. You'll get an error. See here, argument 4 is empty. That means there is nothing after comma 4. Okay, so you just try and understand the error as well, so that will help you. Yeah, so quote is compulsory, guys. So there's one question, a good question actually. Okay, how do we differentiate between integer and a character? So there is only one point of differentiation. Okay, don't think that I'm writing hello, uh, since hello is a character that is there, but how do we interpret? How does R interpret? R says if it is in quote, it is a character. If it is without quote and digits, it's an integer. Okay, that is how it quotes. Okay, now
But
mute yourself. Okay, yeah. So now think of a situation. Okay, you did a vector operation. You added 2 integers. Can we add this? If I create, if I created b as an integer, c as something. Let's say c du. That's it. Okay, let's say one more. Si. So if, without quote is not acceptable. They have already raised an error. See here. If I give without quote, they raise an error. Okay, it will give you an error. You will not be able to create it. So I created this. I had created 2 character vector. Now I'm trying to add it. It is illogical, but yeah. Again, see here. What is the error? Non-numeric argument in a binary operator. Plus is a binary operator. It is used for adding, subtraction. It's an addition or subtraction is a binary operator. I'm trying to add non-numeric arguments. That means character. Obviously, this is what we thought of. We cannot add characters, right? But at the same time, if you give integer, if you try to add a and x and y, it will be added. There will be no error. Okay, x x plus y. You got the output. So this is how. So you perform all the vector operation on numeric, right? So likewise, so it will be the same. So what I said is applicable here. The entire vector operation, you can do it here. Okay. Now take one example out of the context, but I'm creating a variable a and assigning it 10. I'm running it. I'm not getting the output. See, I'm getting the output. No. Okay, why? Because output is not getting displayed because the value of 10 is assigned to this variable a, but I'm not asking R to print the output. R will only print the output when I'm explicitly typing a and running it. Then it gets the output. Agree? Fine. Now, so there are some functions like length x. I ran here length x. So length a is giving me if I run length a, if I just select. So this is again another way to run the code, guys. Just keep yourself handy with it. Okay, if you want to run some part of the code, okay, some particular line, a particular word of the code, just select it and run it. Okay, it will run very so. It is very useful at times. So I selected length and I length x. So x is this. X is this. Where is x? So x is why it is 3 and I'm getting output as 4. Let me check. Yeah, this I must have declared something in between. Yeah, so I'll declare x again. Okay, and I try to find the length of x. So length of x is 3. Okay, yeah, it is 3 actually. Okay, so I'm getting a length of x as 3. I'm getting the output directly. But if I run this way, a length of x is getting assigned to a variable x, a, then I'll not get the output C here because the output is getting stored somewhere, and it is getting stored in a variable which is created here. Okay, a. Then I have to run this again. Then I get the output. This is the way it works. So you got the logic, right? There are something which will directly there are some operation which will directly give you the output. Okay, there are something which will assign the value of output to some variable. Then you will have to run that variable to get the output. Guys, clear? Yeah. So Triyanini, you have some question, right? Sorry with the names.
Yes, sir. I have a question that when I'm
be a little slow. Yeah.
that when I'm entering in the input section something that be what have you that hi, hello, and hola thing.
Mm-hmm.
I am getting some equation in my R Studio page. It's in the output section. I'm getting an equation something of 2 plus 2 z is equals to 3, which is
So,
different from what you have done.
okay. So there's some. You just clear your screen, right? So fine. Do one thing. You can at the end of the session you can share your screen and show me what is the problem. Okay.
Okay,
So,
sir. Okay, sir. Thank you, sir.
no. Yeah. So there are two questions. Okay, and the first question is what is this L here? 3L, and sometimes you're getting 4L. Okay. So it is a like I can tell you is an internal representation of a variable. Okay. So basically, if I declare declaring a variable, let's say a, I declare a variable a. Okay. So what is it? It is having it is integer plus character. It is getting displayed here. Okay. Now if I declare a sometimes, so when it is a mix basically, so Yeah, declare this A. So it is not coming. So basically, one L shows integer. It's an integer representation. Okay, it's an integer representation, and make sure that you will not see it very on a regular basis. Most of the time, you will see numeric, but at times when you declare a variable, sometimes you see L. So L is integer. Okay, this is one question, and the second question was, can you declare a variable, two variable with the same name? Okay, so sorry to say, you guys, that does not work here. Okay, and if I declare a variable a as 10, and again I want to declare a variable a with a value, let's say value 11. So this value of 10, so let me make you understand this way. Okay, you're able to see my screen, right? I'm writing something. Guys, can you see my screen? Okay, great. So fine. So see, yeah. So I have a variable a in my R. I have declared a as 10. So this has 10 value of 10 here. Okay. Now I declare a variable a again. Okay, and I want to assign a value of 11. Okay. Now I go to R and I try to see what is a. So the output will be I get 11 as a output. So the reason is these two are the same variable. Okay, earlier it was 10. Once I declared 11, so this 10 got replaced. Okay, 10 got replaced with 11. Okay, 10 got replaced with 11, and the latest value will be displayed here as an output. Just remember this thing. Guys, doubt? Any doubt? No? Again, come here. If you see a and a is same variable. Okay, but R is a case sensitive language. Just put this somewhere in your brain where you can have it, you can recall it every time. Okay, don't do this mistake because this will raise a lots of issues. Okay, so that's why I'm telling you, keep this thing like stored somewhere. R is a case sensitive language, programming language to be specific. Okay, if I declare a variable a is equal to 10 and I declare a variable a is equal to 20, this means different. Okay, a is different, caps A is different. See here, two different variable has been registered in the memory in the environment. Okay, now if I query A, I get 10. Okay, if I query caps A, I get 20. Fine. I guess you are okay with it, right? No issues. Great. Let's move ahead. Okay, we are moving. Yeah. So we saw vector operations of addition, subtraction. Okay. Now let's see some more operations. That is, we saw a length. How to, if I declare a variable, I want to see, I declare a vector, I want to see the length of vector. I can see it. Okay, like this, length and x. Now to enhance your like knowledge on vectors, okay, simple, right? Vector, okay, vector class, and search for it. So see, there are a lot of information that will come in here. I just question to learn further. I just queried it and I got the output. Now, if you want to see more, there are many things that you can learn R from help only if you just try and be inquisitive. I want to see what is length. Okay, so it says get or set the length of vectors, including list. Right? So it will give you the value. Yeah, addition function of a vector is just simple. If you want to add x and x plus y, you create two vector and you try to add it. Okay, x and y is not there. Let's create it. X and y are created. X and y. I want to add x and y. X comma x plus y. Okay, it simply got added. So how it is getting added, that is the question. Okay, element wise. 2 plus 9 11, 3 plus 7 10, 7 plus 3 10, 9 plus 6 15. Now let's suppose, okay, you have uh, a mismatch in the number of, you have 10 here. Okay, so it will never match because there is the first vector has 5 elements. The length of the vector is 5. The second vector has a length of 4. Okay, if you try to add x and y, there's a mismatch in length, and that is what straight away R says. Longer object is not a multiple shorter object length. Okay, so it does not work. Like if you just try to basically try to add a vector which is of not same size, so it will never work. But like in a list, okay, or that will come to see that in that case it will work. But in a vector, if there's a mismatch in the length of a vector, you cannot perform any vector operation. Yeah, so that is done. Now let's move ahead. Now creating we just saw how do we create a variable. C 1 2 3 4 5 6 by separated by comma, but there's something, a very convenient way to declare a variable in R. And let's say you declare a variable z, okay, where you want to see like a number from 1 to 100. Okay, 1 to 100. So 1 2 3, you can keep on writing, okay, till 100. Okay, or other ways, the smarter way is 1 colon, okay, 100. So what R understands, that you are trying to declare a variable z which will have a integer value from 1 to 100. So just see it, 1 colon 100, enter it and try to see the output of z. So you'll see 1 to 100. Okay, guys, am I clear on this? Okay, now if you want to do the same thing, let's say a 1 to 10, and you want to repeat it 10 times. Rep. Okay, first before we go to rep, just try and understand what is rep. Okay, so how will you understand? No need of Google and everything. Just type question mark rep, enter it, see what is rep. It will give you rep replicates the value in X. It is a generic function that, and the internal default method is described here. Okay, so this is the way. Now if you want to see the code, simply rep X. X means like what you want to replicate. Okay, times means how many times you want to replicate. Okay, and there are some values which you don't need, but it is there. Like let's say I copied this. Okay, you put it here. So I'm like trying to explain you the best skipping way. Okay, so rep, I want to replicate what? 2. How many times I want to replicate? 10 times. Okay, I want to store this into a variable called y. Okay, now y, see, 2 is getting replicated this many times. Okay, this is how. Guys, are any doubts in this?
So please repeat the function of replicate.
Yeah, replicate. Just repeat it. Before that, if you are having R, just do a take a help from like question mark and rep, and or you can read it from here. It's very self-explanatory. It's used for replicating. Okay, so that is what that is how we use replicate. Fine. Uh, yeah. So that's a smarter way of declaring variable. And if you want to do, like, let's say the same thing is applied for character as well. If I want to replicate character, I love R. Okay, and I want to replicate it 100 times. Okay, declare it. Now I want to see the value. Just run it. So see, I love R is replicated 100 times. Okay, now this is my, let's say this is my Z, this is my Y. Okay, now let's see the object size. We already saw, so object size of Z is for 440 bytes. But for some reason, we understand that since Y is big and it has 100 replication, it should have bigger size, and that is what we see. So X is, your Z is replication of 210 times, this 440 bytes, but the Y is 896 bytes. So just the size to evaluate uh, like the concept. That is it. Okay, so we understand replication, we understand colon, so we are good to go ahead. Okay, just keep on taking the help of help of this R help. Okay, this is very useful. Okay, guys, so we'll do one thing. I'll share the documents that we have for whatever we discussed and the PPT with you. Okay, and let me quickly go through before we end up for today. Average computing performance is done. Visualization we'll see. Yeah, I'll just quickly show you, not the coding, just the this packages we have seen. I just want to explain the fourth quadrant. Okay, great. Yeah, so we have seen help and we'll be seeing help a lot. So be assured with that. Then comes packages. Packages we have discovered a little bit. Let's see plots. Okay, so let's say I want to plot something. Plot. Okay, I want to plot. Say I'm creating a variable X. Okay, rep 2 20 times and Y, but this will not give you any decent output. So I want to plot, let's say there's one data called empty cars which we'll see, but now I want to see the plots. Okay, so you do any plotting, this will just become very complex. Sorry. Just I'll do histogram plot. Okay, so yeah, so the core essence of it is do any plotting, leave the code. So that will come in plot. So you see the plot here. You can see all the visualization here. Okay, and you can zoom it. Okay, and you can export it if you want to export and bring it to you want to save it. You can export wherever you want, save images. Okay, wherever you want you can export it. Okay, and then we have seen packages, we have seen help. Okay, we very rarely use. Then comes files. Files is basically all wherever you have installed R or whatever your working directory is. Okay, the second thing is wherever your default working directory is, so R works on working directory. Okay, now what is working directory? R works on working directory. What I mean is, whenever you uh, install R, okay, by default working directory is document. So for me, the working directory is documents. This is my working directory. Okay. Now let's suppose I want to change my working directory to this. I want to change. This is pictures, right? So let's make it this only. I want to change it. Okay. I want to keep this as a working directory. So what I'll have to do is, here I'll have to go and explicitly change it. Okay. So first we'll have to check how to get the working directory path. So you just need to write get wd working directory. Okay. So run it. So this is the working directory of mine, by default working directory. Okay. That means whatever files I'm getting here, okay, you copy this path and paste it here. Whatever files I'm having here, okay, so these files will get displayed in your files folder. See here. And this is very easy way to access it. If I want to access visualization, I can directly click and it will open here. You're getting my point? Okay. And then if you want to change to some other directory, now I want to change it to set. I want to change, then I want to write set working directory. Okay, then I have to give the path, whatever I want to change it to. Let's say I want to change it to some path. Okay, and you can give that path, and then it will change the path. So I'll 1 minute. I'll copy some path from somewhere. Python. I want to change the path. I want to change the path to documents Python. So it might be a little different because I'm using other operating system. So in your system as well, you'll get the same thing. Okay. So now I want to change my working directory from that document slash training slash art training to only documents, and I run this. Then I check the get working directory. So my working directory is changed. Okay. Then if I reopen my R, okay, I'll not get these files here. So I'll get the files which is there in this folder. Clear? So if it is confusing, leave it. Okay, just concentrate on the plot, packages, and help. That is more than enough for now. Okay. Yeah. So we'll continue tomorrow with the more advanced topic. Okay. For today, if you have any